I want to show you a map. This is all of the virgin forest in the United States 400 years ago. And this is 200 years ago. And this is 100 years ago. And you can imagine what the map looks like now. Our original natural forests are gone. And at the same time, we're facing skyrocketing greenhouse gas emissions, a mass extinction event, clean water shortages, and devastating wildfires that are now the norm. In other words, we really need our forests back. So how do we do that? We could try planting trees ourselves. In fact, lots of people plant their own trees as a kind of DIY project. Here's a professional forester planting trees in Pennsylvania, but do you see how hard this is? So I'll say this again, this is a professional forester. He spends most of his life in a forest, and it's still not easy to do. Okay, so you want to plant more than a dozen trees, can't you just hire someone else to do it? Well, there are tree planting contractors, and they plot hundreds of acres at a time. This is how governments and large nonprofits typically plant their trees. But unless you give them hundreds of acres to work with, you're just too small to be worth a contractor's time. So there's a gap between small land that you can reforest yourself and big land that you can just contract out. Okay, so we'll design some kind of mechanism and tow it behind a tractor. All right, in fact, that's actually how commercial orchards operate, but you end up with a commercial orchard, not a forest. You get trees in evenly spaced grids, an unnatural ecosystem that animals and wildlife steer clear of. So you end up with the opposite of what you aim for at the beginning, a biodiversity desert. So fine, now we have AI and IoT and drones. Let's drop seeds from the air using drones. Well, that's a great idea, but it turns out that shooting seeds from hundreds of feet in the air doesn't lead to very good survival rates. In fact, as Wired pointed out, reforestation by drone gives seed survival rates of 20% at best. And at the same time, the supply chain for tree seeds is completely overwhelmed right now, so we really can't afford to waste a single seed. All right, we can't do it with human labor, or conventional mechanization, or drones. But what if we could combine the cutting edge of AI and the grace and dexterity of traditional planting techniques? So that's what we've done here at Carnegie Mellon. We've built Steward. Steward is a rugged, all-terrain robot with a planting drill. We're also designing a chute to carefully lower seedlings into the ground and a tamper to gently pack in the soil just like a human does. You see, it's critical that seedlings are planted correctly every single time. You can't have air gaps, you can't have curves in the root system, and the height of each seedling has to be perfect or else the seedling won't survive. We're working under the technical guidance of professional foresters from the state of Pennsylvania, and we'll begin field tests with our robot this fall. In the meantime, I'd like to show you today how easy we've made it to plan an entire forest using our software in under a minute, and how our software hooks together with our hardware prototype. So this is what a roboticist like me would typically see. It's some kind of crazy interface from the 80s, lots of stuff happening, and of course on the right we have our computer code and a terminal with a lot of warnings on it. We can't give this to a forester. This looks horrible. So instead, what we've built at Carnegie Mellon is a simple web interface, and on the right we have a simulator instead of our physical robot today. The simulator is of Flagstaff Hill. This is a park right next to Carnegie Mellon, and we're going to plant a forest today in Flagstaff Hill. On the left, we have a map of our planting area, so you can actually plant anywhere in the world using our publicly available map data. And to plant a forest, if you can paint, you can plant. All you do is draw where you want your trees. So I happen to know that there's a big concrete pavilion in this park, and so I don't want to plant there, but let's say I want to plant some trees around it. In fact, you can actually plant a forest in any shape you want. This looks pretty good to me, so I'm going to hit confirm bounds. And right now our system is generating an optimal forest plan given my parameters, and you see that took just a few seconds. So in a few seconds, it's optimized for the perfect seedling spacing of each individual seedling in 3D. And it's also given me a seedling count and an estimate of how much carbon I'm sequestering per year for the specific species that I'm planting. So today we're planting an oak forest, which is native to Pittsburgh. So this looks pretty good. The final step is sending this plan off to the robot. So you can see all I did was paint and confirm, and now I have to hit the play button, and that's it. So our robot immediately starts, and under the hood it's generated a whole route to go from individual seedling to seedling in the best time, a local plan. It's actually avoiding obstacles, so if there's a boulder or a pit in the ground, it'll go around it, and if it actually gets stuck, it'll back out on its own, it'll do some spins and keep on driving. So in other words, the forester, after the landowner hits that play button, they never have to worry about the robot. They only have to come back to load more seedlings, and that's it. I did want to show you our physical mechanism as well. You can see our auger operating on a custom Cartesian rail system. We're currently finalizing our designs for the seedling, shoot, and soil tamper as well. We've linked our mechanism with our simulator so that when the robot reaches a planting point in the simulated world, it sends a signal to activate the real-world mechanism. So that's Steward, an open-source reforestation robot we're developing at CMU. The code for our core software, our simulator, and our web interface are all available on GitHub, linked in the description below. We're looking forward to showing you more, including real-world field tests in the coming months. Until then, thanks for joining us for our demo.